So you might guess that our stack is Rails. And before we go into MCP itself, I want to talk to you about a domain of the application that we used for our hackathon. So it's Open Air Race Tracking. There is a company named PLRUG. It has a Ruby application running Ruby 2.0 and Rails 7.2. They have these little trackers. These trackers connect to the GPS and send the position of the participant every second or so through mobile data. The PLRUG application also hosts a map that you can track participants live. Each of these blue tags is a participant, the other colors are organizers if they have tracker. This is a event last Saturday, so this event starts from Przemyśl and goes to Zakopane. It's over 500 kilometers long. Notice this tracker number 7. It's way off from the road. Probably something happened to them. Maybe their wife went into labor. Never mind. What has to be done is they need a status did not finish. So how does the organizer set the status in the application? So you would imagine that they would take their phone, open the PLRUG app, navigate the UI, search for the participant number, and tag them as did not finish here. This is the screenshot from admin panel. They use AVO. And it's quite easy to use if you get around the UI. But this is not what happens, because this is somewhere in the forest where the internet is spotty at best. So the way the PLRUG handles this, setting these statuses, the organizers use a WhatsApp chat and send the messages to PLRUG team. PLRUG team handles setting the statuses. This is this is the screenshot from a real WhatsApp chat from the event. In this case, they were sent a screenshot of the SMS they got about someone not finishing the race. So as you can imagine, this makes it's troublesome for PLRUG team because they have to monitor the chat constantly and respond in timely manner, often on the weekends. The other thing that happens is some participants just do not start the race and they need to be tagged as did not start. So this usually happens by organizers sending the screenshot, photo of the trackers that were left on the start. Again, it's not a lot of work, but you have to be there and respond. Okay, so we know how the PLRUG works. Let's go back to MCP, our Model Context Protocol. So what is MCP? It's all in the name. It's the protocol, so it standardizes how we send information. The information is about the context of the application or a system, and the context is passed to large language model. MCP uses standard client-server architecture. The client and server talks to each other through HTTP or STD.io, but in context of web application and our use case, STD.io is not useful at all, so let's stick to HTTP only. Client, in this context, is an AI-powered application. So, for example, this is your cursor client, Visual Studio Code or Cloud Code or Cloud Desktop. They handle connection with the server, authorization, and communication with LMM. On the other side, we've got server. Server is just a piece of software that accepts HTTP connections and responds according to the protocol. Then in Ruby ecosystem, we have three major MCP servers. One of them is Fast MCP, Ruby SDK, and Action MCP. In MCP, we've got primitives. These are functionalities or capabilities the server and client can implement. They don't have to, but it would be nice if they did. The capabilities are negotiated at the beginning of the connection between server and the client. The last thing to mention is OAuth. So the MCP from a few months ago, the standard from a few months ago specifies that it will be using OAuth 2.1, I think, for authorization. Oh, I also forgot to talk about the capabilities a bit. The server can have tools, resources, and prompts. Tools are basically calling your functions in the code. Resources exposes the data to the client and LMM. And prompts are just saved prompts that user can reuse to save typing or maybe guide them to have the prompt that you expect. The client can provide sampling. Sampling is basically sending, the server can ask client to communicate with LMM and give back the answer. Elicitation is asking for user permission to do something. And logging basically means the server can send over logs so the client can inspect them or save. And the last thing, the MCP logo. Since we have a lot of logos here, have this one too. Okay, so enough of the theory. You can go way too deeper into that, but let's not focus on that right now. So what we wanted to achieve in our hackathon, like Mariusz said, we wanted to build a proof of concept of MCP server for PLRUG's application. And we set out with some goals. We wanted to gain and spread the knowledge about MCP servers in our ecosystem, and this presentation is a part of spreading. To do that, we organized a team of 4 programmers. This is us last week doing this MCP server. If you look behind this glass, there is Mariusz, and he is standing in the PLRUG's office, so now you know why PLRUG's. And back there's a bunch of these trackers charging. So the other thing we wanted to do is have something presentable. So what we meant by this is that we would show the outcome to the PLRUG's team, the client basically, but we didn't want to use, I call them developer class tools. So we didn't want to use a client for that, for presentation, because this is not a tool that they would market to their users. They want something available like ChatGPT or Cloud Code that we chose because I use it as a daily driver. We wanted to deliver something valuable for PLRUG's. So to do that, we organized a meeting with a domain expert. So that was Staszek, the developer behind PLRUG's. He told us about the problems they face with setting the DNF, did not finish and didn't start statuses. And also Sebastian came up with the nice idea to provide some new functionalities. And this functionality was to provide a context about the race to LMM, so the spectators can chat with LMM about the current state of the race. We wanted to use variety of tooling to have a better grasp on the different tools, not only one. So we tried to use all three: fast MCP, Ruby SDK, and Action MCP. Unfortunately, or fortunately, Action MCP requires Rails 8 and PLRUG uses 7.2, so we couldn't have tried that in our hackathon. And our last two goals was to identify the rough edges, to know what so we were set against later on, and have some opinions about this. Okay, so once we had PLRUG running on development machines, we started off with using fast MCP. So to use fast MCP, you have to do a few things. First, add again to the gem file and bundle install. Then you run a task with generator. It creates a configuration and sample tools and resources, I think, that you can use. Then we build these tools that we were set off to build and work in a loop with testing and improving. So how do you use the initializer here? This is the thing that comes from the generator. It just Rails initializer. FastMCP registers as middleware in your rack stack, so you don't really have to do anything else other than just doing this and having tools. And it exposes traffic on M8, catches the traffic on MCP/SSE. Notice this localhost only flag. This one gave us some trouble. So when we went on to test our integration with the real thing against Cloud desktop, we had to set this to false, but it wasn't greatly documented. There is also an authorization option, but it would just compare your hard-coded token here, so it's not useful in context of allowing everyone to use this MCP server, unless you provide a client yourself, but that's not the easiest thing to do. Okay, FastMCP provides a quite nice tool, DSL. You just create a class and inherit from this application tool that is provided for you. You set the description, create these arguments. It may be required or optional. Give description to each of these arguments and define a call method. It may do what you want, just return a string at the end. So I won't be showing the tools that we created because that's not really relevant here. Then once we got this working, we went into migrating from FastMCP to Ruby SDK. That was a bit trickier to do, but you can help with that by reading Paweł's article on our website, where he describes these tools and how to set them up. But long story short, you add MCP gem. By the way, awesome naming. They picked the shortest possible name. And there is no initializer. You have to create a controller, add a root. Usually it will be /MCP. Create tools, migrating from one from one set of tools to this Ruby SDK was very easy. It's basically the same thing. And again, test and improve. So our controller has one action. It handles post at MCP, and we simply pass it to MCP server new with defined set of tools. Here we just call this MCP server with handle JSON. Notice this strange looking, out of place looking params bit. So this was put here to accommodate a bug, I think, in Cloud Desktop that simply didn't respond to standard 200 request, and we had to respond with 202 to this one specific message. Otherwise, you wouldn't see the tools in the code. So this is one thing to look for. So Ruby SDK DSL is pretty similar. We create a class, inherit from the MCP tool in this case. We provide description, input schema. It's basically the same, just in hash format. And we have this required set field here that we need to provide. There are annotations, but I strongly believe all the clients available simply ignore this anyway. The main difference is that the call is a class method, and instead of returning string, you return this MCP tool response. Okay, I mentioned that using each of tools ends with testing and improving. So we use two things for this process. One of it is the MCP inspector, is the tool to go provided by Model Context Protocol. It looks like this. I won't be going into the details because it has everything. I believe this is the only tool in the whole MCC ecosystem that provides all the functionalities of the protocol. I may be wrong, but that's my guess. In here we see a list of tools we created with the description. We can call it and get the result. The thing I like the most about this tool is authentication settings. It lets you test your every step of protocol and give very helpful errors and things that are not working and why. Highly recommend it. The other thing is this developer class. Clients that we used, turns out each of us use a different one. So we tested against client, cursor, Ruby, LMM, MCP from the console, and Cloud Code. Here we simply tried to chat with the LMM and have it use our tools. So if it didn't use the tools as expected, maybe the prompt needed to change. If it's called with the wrong parameters, again, we need to alter our tooling until we've got something working. And it was really easy to do, so that's good. The last part of the process was to present our creation to the client. So the biggest problem was to select a normie tool, a normie client that end user could use. So again, ChatGPT or Cloud Desktop. The minus is you will need a paid subscription in both of these tools to use custom MCP connectors. And the Cloud Desktop required this workaround in controller that I showed you, which again wasn't documented. I only found it out when I traversed the GitHub issues of Ruby SDK. So in order to connect to Cloud Desktop, we needed to do two things. We need to expose a client, the development environment, to the internet, because Cloud Desktop does this nice thing. When you set a connector, register it in your client, it's also accessible from your phone and through the web interface, so that's cool. And it requires HTTPS. So to do that, you would have to do two things. Install ngrok. If you're not aware, it's just a tool that would expose, after running this command, expose your HTTP connection to this URL is forwarded to port 3000 on your local machine as long as the as it's running. And we also need to use to allow hosts. Otherwise, the host authorization middleware would just refuse the connection. Then we could go to our cloud, register the MCP server, just to give it some name, and provide the HTTPS, this URL from ngrok and /mcp, and voila, we see the tools available for LMM. Okay, so now it's time for live demo. I have to put this down. Thank you. And speak much louder. Okay, so I have ngrok running right now. I have the Rails server running. Let's see if we see the tools, if Claude see the tools. It does. So let's ask it about something. Hi, can you tell me how is the race going for participant number 10? Spell it almost correct. Typos are expected because that's how the users type for 2LMM. Oh, it deducted that it needs to call the get participant information tool. So let's allow this once for now. And let's see. Turns out there are 2 participants with identifier number 10. So it's correct to ask for clarification. Let's say that I meant Isa to make it harder. Isa is shorthand for Isabella. Okay, it figured out they want Isabella. And here it is, live from seeded data. But, oh no, Isa tripped and broke her leg. What will it do? But it said DNF, it didn't call for ambulance, so who cares, right? Let's allow this just once. We added a safeguard that Isa is still on track, so it may be a typo. Let's confirm that Isa did in fact broke her leg and won't be running anymore. Allow again. And yay, Isa is no longer running. Other thing we can try is getting this image that maybe let's start a new chat. Let's take this image, I just pasted it in here. The image is the one that you saw in the very beginning. It will maybe get bigger or no. Set this as DNS. Did not start. So it read the number from the trackers. It were accurate. And do we want all of them? Okay, let's do all of them. And it's calling the set did not start tool for each one of them. I already allowed him to call this tool automatically, so that's why there is no prompt. All these tools will fail because seed data is not taken from it doesn't match the chat, so don't worry about this. But it works. It calls each tools individually because the tools just accepts one integer. Okay. It will just go on and then probably say that it didn't work for most of them. You can see what the request was, what the response was here. But it works. Oh, I've lost my mouse. Okay, can I get it back? Thank you. Okay. So the rough edges that we identified. Authorization was the biggest of them all. The protocol specifies that you can use OAuth, but there is no implementation in the tools itself, so you have to implement it yourself, by yourself. And you can use third party or authorization providers like Google, or you can try at least, or roll your own server, so that's very nice. But there is no ready solutions, off-the-shelf solutions that we could use. There are also no materials or guides, blog posts, nothing yet. So there is room for improvement for the whole community. There are no popular free clients available. So like I told you, you would expect as a user to use ChatGPT to connect with this application, not some thing that you install from GitHub and then provide API key, and the README in the GitHub is half in Chinese, because that's how it looks like right now. So that's a big issue here. And both of the tested servers and clients are not feature complete yet. Like I said, I don't think any piece of software implements the whole MCP right now. There's also this SSE versus streamable HTTP issue. So from the beginning, the MCP protocol, so it was around last Christmas, specified that the server will respond with server-side events, and many tools were created back then and still use server-side events, but a few months ago they switched to something called streamable HTTP. It also cites server events, but with an extra twist. And many tools do not have this yet. Okay, so I prepared a comparison of these two tools that we used. So FastMCP uses server-side events only. It hasn't moved to streamable HTTP yet, while Ruby SDK only supports streamable HTTP and STD IO. FastMCP provides support for tools, resources. Ruby SDK also have prompts, so that's cool. And FastMCP works as a middleware in the Rails app, in the RAG stack, and it provides Ruby Rails initializers, so it's more integrated into the Rails ecosystem, while Ruby SDK requires a bit of manual work. And the biggest advantage of Ruby SDK is that it's backed by Shopify is the official implementation. And also keep in mind that this comparison is valid now. As far as I know, the person behind FastMCP is already working on supporting streamable HTTP, and Ruby SDK is working on redesigning their DSL, so nothing will stick. Now let's talk a bit about MCP itself and the current state of the ecosystem. There are a few issues with these. MCP, like I told you, with SSE evolves fast. It evolves faster than the maintainers of tools can keep up with. Maybe it's a good thing for the MCP itself, but the market and the tooling is not ready for it yet. Server libraries and clients are not feature complete yet, so it's hard to give something that's ready for production use right now. There is no easy way to deal with authentication yet. I hope this will change very soon. And to be honest, right now, if you are going to build AI integration into your application, I wouldn't recommend doing it with MCP, because most likely you will have to provide your own client. And if you do, you can just create a chat and use tool calling in your application. That simply removes all moving parts from MCP. But the idea behind MCP is very good. It solves the potential problem that doesn't exist yet, this M times N problem, where many clients want to use your application. and you don't have to integrate with each one of them. You just provide one MCP endpoint. And if MCP wins and becomes standards, I think we will be building a lot of these, but maybe not.
Thank you
Thank you very much.